Hello everyone, my name is Ravi Ranjan Kumar and I am going to discuss JEE Main September 4th morning shift physics paper. Okay, so let's start here. That is JEE Main 2020 September morning shift, okay, and physics paper. Okay, here is the first question for us, and that question is from the chapter of waves. And let me read the question for you. For a transverse wave traveling along a straight line, the distance between two peaks, which is crest, is 5 meter, while the distance between one crest and one trough is 1.5 meter. The possible wavelengths in meter of the waves are. Okay, so before approaching this question, we must understand the definition of crest and trough. Okay, so if we are having a wave pattern something like this, okay, all the peaks are known as crest. These are crest, and the bottoms are known as troughs. Okay, and you must also understand that the distance between the two consecutive troughs can be defined as the wavelength of the given wave. So obviously, the distance between the two consecutive troughs and crest will become half of that, and that will be equal to lambda by 2. So you should realize, so here they have given the distance between two crest is 5 meter, and they need not be the consecutive ones. So what we can say that this n times lambda, the distance between any two crest would be some integral multiple of lambda, and n lambda is given to us as 5. Okay, so let's say that is equation number 1. We have got n is any integer. Okay, and similarly, it is given to us that the distance between one crest and one trough is 1.5 meter, and that crest and trough need not be consecutive as well. And you need to understand the distance between the crest and trough would be a multiple of lambda by 2, and also you need to understand that that multiple got to be an odd number. Okay, so I can represent it like that. Let's say something 2k minus 1 into lambda by 2, and that will be equal to 1.5 meter over here. So that is equation number 2. And simplifying, like using these two equation, you can arrive at the conclusion. Since lambda is same in both the cases, you can arrive at the conclusion that n upon 2k minus 1 is equal to 5 by 3. So this is one of the fraction. Another other way, how can this fraction can be written, keeping in mind that denominator got to be an odd number. So another possibility is 15 by 9, and the next possibility is 25 by 15, and so on. Okay, so from that we can see that n can be any of these values like 5, 15, or 25, etc. So these are the corresponding value of n. So the value of lambda, corresponding values of lambda, since lambda you can say that would be 5 by n over here. So corresponding value would be simply 1 or 1 by 3 or 1 by 5 and so on. So looking at the options, you can definitely see that the option 4 is the right choice for question number 1. Okay, so now let me move on to the next question here. Okay, so the next question is from the chapter of calorimetry, and the question is pretty simple. The specific heat of water is given to us as 4200 joule per kg per Kelvin, and the latent heat of the ice is given to us as this 3.4 into 10 to the power 5 joule per kg. 100 gram of ice at 0 degrees Celsius is placed in 200 gram of water at 25 degrees Celsius. The amount of ice that will melt as the temperature of water reaches 0 degrees Celsius is close to. So this is simply the case of principle of calorimetry. So what here we are doing is we are mixing 100-gram ice, which is at 0 degrees Celsius, to 200 gram of water, which is at 25 degrees Celsius. And principle of calorimetry simply suggests that the heat lost by the hotter object will be equal to heat gained by the colder object, you can say. Okay, so heat lost by the hotter object, which here is water, will be simply the formula will be ms delta T. So mass of the water in picture is 200 gram. So that is 200 gram, and simply you can say that is, let's say, 200 gram with unit, let me write, and its specific heat capacity is given to us as 4200 joule per kg per Kelvin, right? And the change in temperature, like water's temperature is changing from 25 degrees Celsius to 0 degrees Celsius. So decrease in temperature is simply equal to 25 degrees Celsius. So 25 degrees Celsius temperature change is same as 25 Kelvin temperature change. And heat gained will be like this heat lost by the water will be utilized by the ice in order to change its phase from solid state to liquid state. But how much ice will be melting over here? A lot of ice we are seeing that is present over here. The heat is not sufficient to melt all the ice. So let's say only mass m of the ice, m gram of ice is melting. Okay, and its latent heat is since 3.4 into 10 to the power 5 joule per kg, right? So here m is unknown, and see, joule per kg etc will get cancelled and Kelvin will get cancelled. So m which we will be getting over here is simply in grams. Okay, so m will be, the calculation wise you can say, that would be 200 into 4200 into 25 upon 3.4 into 10 to the power 5. Okay, so here after solving a little bit calculation is there, but after solving you will simply get it as 61.76. Okay, so I guess that option 1 is the best choice. Okay, so that is for question number 2. Now let's move on to question number 3. Now this question is also a very simple question, that is from the current electricity, and we are having a battery of 3 volt is connected to a resistor dissipating 0.5 watt of power. If the terminal voltage of the battery is 2.5 volt, the power dissipated with the internal resistance is. So let's draw the circuit first of all. Let's say this is the cell having some internal resistance. So this is the cell. Okay, and its EMF has been given to us as 3.0 volt. So that is EMF. Okay, and it is connected with some resistor. Let's say this is the external resistor. This is internal resistance, and the external resistance is a capital R here. Okay, and it is also given to us that the terminal voltage of the battery, like the voltage potential difference between the terminals of this battery, is given to us as 2.5 volts. So you can also say that 2.5 volts will be the potential difference uh, across this resistor, the external resistor also you can say. Okay, and since it is given to us that the power dissipated across the resistor is 0.5 watt, we are required to find out the power dissipated in the internal resistance, and you need to realize that the current passing through both the resistors are same, and we can use the formula for the power dissipated here as P is equal to VI. Since the current passing through both the resistor, the external resistor as well as internal resistor, is same, so we can simply conclude that P will be directly proportional to V, where V is the voltage across the given resistors. So we can say here that the power dissipated across the internal resistance upon power dissipated across the external resistance will be simply equal to voltage across internal resistance upon voltage across external resistance. So here you can see simply voltage will be divided. So 2.5 volt this is, and EMF is 3 volt. So voltage across this resistors, internal resistance here, will be simply 0.5 volts. So this is 0.5, and V capital R is simply 2.5 volts. So here power dissipated across the internal resistance would be 0.5 upon 2.5 into power dissipated across the capital R is given to us as 0.5 watt. Okay, and solving, obviously you will be getting 0.10 watt. I think option 4 is the correct choice. So that is for question number 3. Now let's move on to the question number 4 here. So this is question number 4. On the x-axis and at a distance x from the origin, the gravitational, I think gravitational field should be written. Gravitational field is given by this expression. The magnitude of gravitational potential on the x-axis uh, at a distance x, taking its value to be 0 at infinity. So that is very, very standard calculation. E is given to you. The gravitational field, the field expression is given to us as ax upon x square plus a square to the power 3 by 2. And we are required to find out the expression for the potential as function of x. And the reference point is also given to you as 0 at infinity. Okay, so by definition, you can say like dv is defined as minus e dot dr. So here it will be simply e dx over here. And if we integrate both sides with appropriate limits, so at x tending to infinity, the potential is defined to you as 0. And at given value of x, we are required to find out v. So these will be the appropriate limits over there. So left hand side will be simply v, and the right hand side will be e is given as ax upon x square plus a square to the power 3 by 2 into dx over here, and we got to integrate it from infinity to x, and just solving you will simply get it as a upon root under x square plus a square. So I think the option 3 is the right choice. So that is for question number 4. Okay, let's move on to question number 5 now. So question number 5 is a simple question of kinematics. This says that starting from origin at time t is equal to 0 with initial velocity 5j meter per second, a particle moves in the xy plane with a constant acceleration of this much. Okay, so at time t its coordinates are given to us as 20 comma y naught. So the value of t and y naught are respectively. So first of all, the initial velocity is given to us, u bar is given to us as 5 j cap, and apart from that acceleration is given to us, and that is 10, I think that is I cap, so 10 I cap plus 4 j cap, and its coordinate, the final like initial position has been given to us like let me say, write it as ri. So Ri is given to us as simply 0, and Rf has been given to us as 20 comma y naught. So I will write it as 20 I cap plus y naught j cap. So all these things are given to us, and we are required to find out the time and the value of y naught over here. And we must appreciate the fact that acceleration given to us is a constant. This acceleration is constant, so we are free to use this formula, that is s is equal to ut plus half at square. Okay, where s is displacement, u is initial velocity, and a is acceleration. So displacement, that is nothing but the final position minus initial position. Okay, and let's substitute the value in the very beginning over here. So final position is given to us as 20 I cap plus y naught j cap. Okay, and initial position is anyway 0, so we do not need to write that, and u is given to us as 5 j cap into t plus half, and the acceleration is 10 I cap plus 4 j cap here into t square. And right hand side, I want to arrange it in a way that like we can get the coefficient of I cap and we can get the coefficient of j cap. So when you will do that calculation, this term you will get it as 5t square, and this term you will get it as 5t plus 2t square. Okay, so now only thing we are left up with is the comparison. Okay, so obviously the coefficient of I cap in the left hand side and right hand side must be equal. So 5t square must be equal to 20. So 5t square is equal to 20. When we will be equating t, I will be getting it as 2, or you can say 2 second. And similarly, if you compare the coefficient of j cap, so you can simply say that 5, let me write it over here. So that is 5t plus 2t square is equal to y naught. And since the value of t now you know, so by substituting, you will just get the value of y naught is equal to, this will be simply 5 into 2, that is 10, and 2 into 4, that is 8. So that would be 18 meter over here. So time is 2 seconds and y naught is 18 meters. So I think option 3 would be the right choice. So now let's move on to the next question. That is question number 6 here. Okay, and question number 6 is from photoelectric effect. Okay, and we have been provided with the graph of V versus the stopping potential versus the frequency of the incident radiation. Let me read that question for you as well. That given figure shows few data points in a photoelectric effect experiment for a certain metal. The minimum energy for ejection of the electron from its surface is. So minimum energy of ejection of electron, basically they are trying to ask the work function of the given metal. And we know from the Einstein's equation that energy of incoming photon h nu must be equal to that will be equal to phi, that is work function, plus E times V. Okay, so this is the expression over here, and we are required to find out the value of phi. So what all data points are given? Okay, so this point B specifically is given to us. So in this point B, we can clearly see that nu is given to us. So nu is given to us as 5.5 into 10 to the power 14 hertz. Okay, so that frequency is given to us, and the stopping potential at this point, that is 0. So V is given to us as 0. So when we will be substituting this data point in this expression over here, this term is anyway 0. So simply phi, we will be getting it as h times nu, and h is given to us as 6.62 into 10 to the power minus 34, and nu is given to us as 5.5 into 10 to the power 14, and this will give us our answer in SI unit, which is joules, and all the options are in electron volts. So we need to convert this energy, which is in joules, in electron volt by dividing it with 1.6 into 10 to the power minus 19. And this is also some calculation here. So, but anyway, the calculation result will give you 2.276 electron volt approximately. And I think then option 3 would be the best choice here. Okay, so that is for question number 6. And now let's have question number 7. So question number 7 is from the magnetic field. This, let me read that question for you. A wire A bent in shape of an arc of a circle carrying a current of 2 ampere and having a radius of 2 centimeter, and another wire B also bent in the shape of arc of circle carrying a current of 3 ampere and having a radius of 4 centimeter are placed as shown in the figure. The ratio of the magnetic field due to the wire A and B at the common center O. And you should realize, like, due to these straight parts, the wire which are oriented along the radial direction, due to this the field at O will be equal to 0. So the field will only be due to the uh, circular arc. Okay, and the formula for the field due to a current carrying circular arc is simply, you must know that B is equal to mu naught I theta upon 4 pi r. Okay, where theta is the angle subtended by the circular arc at the center of the arc. So from here you can conclude that B is directly proportional to I theta upon R, because other terms are constant. Okay, and we can utilize this fact because we are simply being asked the ratio of the magnetic field due to wire A and wire B. So we can simply say that magnetic field due to A upon magnetic field due to B will be simply IA by IB into theta A by theta B and into RB by RA. And now let's substitute the values. So IA by IB, IA is given to us as 2 and IB is given to us as 3, so 2 by 3. And theta A and theta B, you can see like A is subtending this much angle, so that is nothing but how much? 2 pi minus pi by 2, so that is 3 pi by 2. And the uh, arc B is subtending 2 pi minus pi by 3, so that is 5 pi by 3 here. And RB is given to us. RB is how much? RB is 4 centimeter and RA is 2 centimeter. So that would be 4 by 2 here. And simplifying, I think you will be getting it as 6 by 5. So as simple as that. So option 1 will be the right choice. Okay, now let's move on to question number 8. So question number 8 is again from the buoyancy chapter. So a air bubble of radius 1 centimeter in water has an upward acceleration that is 9.8 centimeter per second square. The density of water is 1 gram per centimeter cube and water offers negligible drag force on the bubble. The mass of the bubble is. So now you should realize, since the bubble is basically accelerated upward, that means the buoyancy is exceeding the weight of the bubble. Okay, so what I can say here simply is the acceleration in that case will be the buoyancy, which is upward in upward direction minus its weight upon the mass of the bubble, right? So what we can say over here, like when we will be substituting the value of FB and W, etc. Okay, so that will be simply FB will be 4 by 3, that is equal to weight of the displaced liquid. So 4 by 3 pi r cube into density of liquid minus weight of the bubble will be simply 4 by 3 into pi r cube into density of bubble, like I think like that will be comprised of the air inside the bubble. So that is, I think, the density of air itself. Okay, and that multiplied with G will be FB minus W, and that divided by mass, again that is 4 by 3 pi r cube into rho B. And I think you should remember this formula in this form, that is that will be simply rho L by rho B minus 1 into G. Okay, so when you will be substituting the value of A here, A is given to us as 9.8 centimeter per second square, and that will be equal to rho L by rho B minus 1, and G has been given to us as 980 centimeter per second square. And solving that, you simply get rho L by rho B is equal to 1.01, and rho L has also been given to us as 1 gram per centimeter cube. So effective density of the bubble, you can say, is 1 upon 1.01 gram per centimeter cube over here, and that is sufficient enough for us to find out the mass of the bubble, which will be its volume times density. Volume would be 4 by 3 pi into r cube. R is given to us as 1 centimeter, so 1 centimeter cube into its density. Okay, that is 1.01, 1 upon 1.01 gram per centimeter cube, right? So centimeter cube will get cancelled, and substituting the value of pi as 3.14, you will get it as 4.15 gram. Okay, and I think the option 2 will be the right choice here. So that is question number 8. So now let's move on to question number 9, and this is a problem from kinematics. A tennis ball is released from a height h, and after freely falling on wooden floor, it rebounds and reaches height h by 2. The velocity versus height of the ball during its motion may be represented graphically by graph are drawn schematically and are not on the scale. So you should realize what is happening over here. So let's say this is the ball and a tennis, this is the surface, and tennis ball has been released from some height h. So its initial velocity is 0. Okay, so it has been released, so it will fall, okay, and it will collide with the ground with certain velocity here. Okay, let's say certain velocity would be, let's say, v1, and it will rebound. Okay, and there will be some coefficient of restitution, so that will rebound with, let's say, some ev1. So e is less than 1, so it will not get raised to the same height it was dropped from. So like this height has been given to you as h by 2 here. So that is the idea. Okay, and looking at the graph, definitely this direction has been taken as positive, I guess. So like say this point over here corresponds to h is equal to 0. So from here it has been released. Okay, so this is the point here, and then its velocity is negative, so the graph will be in the fourth quadrant over here. So I think all the entries are valid here, but you should also realize from like it has been dropped from h, and subsequently it will get to the maximum or the peak velocity. So this will some corresponds to v1. Okay, and then it rebounds, and you should realize here that then the direction of velocity will be changing, because it would be moving in upward direction afterward. Okay, so like the first part of the journey will be in the second quadrant, and the second part of the journey will be in the first quadrant. And you should also realize, like, the motion from here to here will be governed by the expression v square is equal to 2 square u square plus 2as, which is parabolic in nature. Okay, so you can see like option 4 is definitely not true. Okay, because here we want when h is equal to 0, we want the velocity or the speed to be maximum, which is not the case over here. And these two graphs are not parabolic in nature. So by elimination, simply you can say option 1 would be true. Okay, so that is for question number 9. And now let's move on to question number 10. That is a match the Cp by Cv ratio for ideal gas with different type of molecules. So that is from the kinetic theory of gases. And you need to know a few things about it, like when we are talking about the molecule type. So molecule type has been given to us, either it is monoatomic gas or diatomic, rigid rigid molecule, and diatomic non-rigid molecule. So these are the type of molecules we are having. And finally, we are having triatomic rigid molecule. Okay, so you need to understand, like, when the atom is triatomic, you need to also figure out whether it is linear or non-linear. Okay, so I think in this question they are trying to put it as non-linear because the data are matching. So let me assume that the triatomic atom we are taking here is non-linear. And you should realize that we must try to draw a table over here. So like here I will write the degree of freedom f, and once f is known to you, it is very easy for us to find out cv and cp. And once cv and cp is known to us, gamma we can find out, which we have to find out as cp by cv, that is required in the question. So once degree of freedom is known to you, cv will be simply equal to fr by 2, and Cp will be simply equal to Cv plus R. Okay, so we need to figure out like what would be the degree of freedom in each case over here. So monoatomic molecule simply have 3 translational degree of freedom. Diatomic rigid molecule will be having 3 translational plus 2 rotational degree of freedom. Diatomic non-rigid molecule will be having 3 translational and 2 rotational and 1 vibrational degree of freedom. And triatomic rigid molecule will be having 3 translational and 3 rotational degree of freedom. Since it is rigid, it will not be having any vibrational degree of freedom. You need to understand from the rigidity, if the molecule is rigid, it is not free to vibrate. Okay, so this will not be having rigid molecule will not be having vibrational degree of freedom, but non-rigid molecule will definitely have. And also you need to understand that each degree of freedom, each vibrational degree of freedom can store energy in two ways. Like one vibrational degree of freedom will comprise of the translational kinetic energy as well as the potential energy also. Like when some molecule is vibrating, some vibration is going, so molecule will possess kinetic energy as well as potential energy. So you need to understand that one vibrational degree of freedom will be having two uh, 2 degrees of freedom inside it, like one translational kinetic energy and one potential energy, right? So let's try to figure out. Then CV will simply be equal to, since degree of freedom is 3, so this will be simply 3r by 2, and this is total degree of freedom is 3 plus 2, that is going to be 5r by 2. And now we have to look very closely for diatomic non-rigid molecules. So 3 plus 2 and 1 vibrational degree in inside consists 2 additional degrees of freedom. So 3 plus 2 plus 2. Okay, so that will be 7r by 2 total. Okay, and this will be simply 3t plus 3r, so 6r by 2, that is simply 3r. And just in order to get cp, you just need to add r in that, so that will be 5r by 2 here, 7r by 2 here, and that would be 9r by 2, and that would be 4r here. So just by dividing, you will get 5 by 3 and 7 by 5 and 9 by 7, and that would be 4 by 3 over here. So I guess the fourth option would be the right choice in that case, right? So that is question number 10. Okay, and now let's move on to question number 11 here. Question number 11 is from the chapter of electrostatics. So let's read the question. A 2-point charge 4q and minus q are placed on the x-axis at x is equal to minus d by 2 and x is equal to d by 2. So this location is given to you as x is equal to minus d by 2, and this location here has been given to us as x is equal to plus d by 2 respectively. With a third point charge q is taken from origin to x is equal to d. So some third point charge is q, which has been taken from this position origin to this position x is equal to d along the semicircle as shown. The energy of the charge will be changing by, like the option is looking for what will be the change of the energy of this charge. So now you should realize when we are moving this point charge q from O to this position x is equal to d, okay, the distance of it is not changing from this minus q charge. Previously the distance was d by 2, and finally the distance will be d by 2 as well. Okay, so the distance from minus q is not changing, only the distance from 4q is changing. So potential energy will change only due to 4q only. So let's try to find out the change in potential energy. So delta u will be equal to simply q times delta v, and this delta v will be the change in potential due to only 4q. So let's substitute the value. So q and delta v will be simply due to 4q, that will be 4q upon 4 pi epsilon naught into 1 by r final minus 1 by r initial. So r final here from this 4q, so that distance is I think 3d by 2. So here you can write 3d by 2, and the initial distance is definitely this distance over here, so that is d by 2, and simplifying you will simply get it as minus 4q square upon 3 pi epsilon naught d, right? So that is which choice? Option 3. Okay, so that is question number 11. Now let's move on to question number 12 here. Okay, so dimensional formula for thermal conductivity is being asked over here. So thermal conductivity, so in order to find out the dimensional formula of a given physical quantity, we must try to relate that physical quantity in some formulas. Okay, so I can think of one of them. So like for example, the conduction current, let's say dq by dt will be equal to A, which is the cross-sectional area of conductor, into K, that is thermal conductivity, into the temperature gradient dt by dx. Okay, so here when you will be rearranging K, you can say that would be dq by dt, and that upon A upon dt by dx. Okay, and let's now try to write the dimension of each and every term. So dq by dt is nothing but energy per unit time, or power, you can say. So the dimension of power is ml square t minus 3, right? And the dimension of area will definitely be L square, and the dimension of the temperature gradient, like the temperature per unit length, that would be simply K into L to the power minus 1, and simplifying everything, you will be getting mlt minus 3 k to the power minus 1. Okay, and which option is that? So I think option 2. So that is question number 12. So now let's move on to question number 13 here. So 13 is from the chapter of polarization. A beam of plane polarized light of large cross-sectional area and uniform intensity of 3.3 watt per meter square fall normally on a polarizer of cross-sectional area this much, which rotates about its axis with an angular speed of 31.4 radian per second. The energy of the light passing through the polarizer per revolution is close to. So you need to understand that when polarized light is passed through the polarizer, okay, so the in outgoing intensity is given by Malew's law. So that is governed by this expression: I is equal to I naught into cos square theta. Okay, where theta here is the angle uh, between the axis of polarizer and the plane polarized light over here, and this theta is continuously changing because the polarizer is rotating with an angular speed of 31.4. Let's say this value is omega. Okay, so theta as a function of time, we can simply write it as I naught into cos square omega t, we can write. So this is the intensity as function of time of the uh, light which is coming out of the polarizer, like the intensity that is passing through the polarizer, you can say. So the energy that will pass in time dt, we can simply write like I is the intensity and A is the area of polarizer. So this is the power received by the polarizer, and that multiplied with dt will be simply energy. And since I value is given by like I naught, so I naught into A into cos square omega t dt, we can write. So that is the energy passing in time dt. Okay, so we need how much energy is passing through the polarizer per revolution. Like in one cycle, basically the time which we are looking for is 2 pi by omega. That is the time of a cycle or one revolution. Okay, so we need to find out the total energy that has been passed. So we need to integrate this thing from 0 to 2 pi by omega. So okay, so that will be I naught into A into cos square omega t dt, and you can integrate it from 0 to 2 pi by omega. And now let's substitute the values. So I naught is given to us as simply 3.3 SI units, and the area has been given to us as 3 into 10 to the power minus 4, and this integral will be the average of it is 1 by 2, and it is integrated from 0 to 2 pi by omega. So 2 pi by omega. Let's substitute the value of omega also. So that is 31.4. So rather I would prefer to write it as 10 pi. Okay, so that is say 10 pi over here. Okay, so here after solving for average, like doing the calculation, you will simply get it as 1 into 10 to the power minus 4 joules, which is option 2. Okay. So that is question number 13. And now let's move on to question number 14. Question number 14 is from electrostatics. Two charged thin infinite plane sheets of uniform surface charge density sigma plus and sigma minus, and also it is given that magnitude of sigma plus is more than magnitude of sigma minus, intersects at right angle. Which of the following best represent the electric field lines for this system? Okay, so let's draw the plates. So this is having charge density as plus sigma, and this is having the charge density as minus sigma. Okay, so let's try to find out the electric field over here. So electric field due to the plus sigma will be away from it. So let's say that is say E plus, and the electric field due to minus sigma will be towards it. That would be E minus. And you should also realize the magnitude of E plus would be more than magnitude of E minus, because the magnitude of plus sigma plus is more than magnitude of sigma minus over here. So the resultant electric field will be in this direction. That means this angle will be greater than 45 degree, you should realize. Okay, so like inclination would be more. And similarly in the second quadrant you can see the electric field due to plus sigma will be in this direction, that is let's say E plus, and that is E minus. Okay, so the electric field will be in this direction, net electric field. And similarly in this third quadrant you can say that the electric field here will be away from plus sigma plate and towards the minus sigma plate. So the direction of electric field will be this, and so on. So I think by this time it is pretty obvious that the option 3 will be the right choice. So that is question number 14. And let's move on to the next one. That is question number 15. So here what we are having is a simple question of collision. That the blocks of mass m, 2m, 4m, 8m are arranged in a line on a frictionless floor. Another block of mass m moving with speed v along the same line, okay, collides with mass m in perfectly inelastic manner. Inelastic manner means the velocity of separation will be equal to zero. The bodies, the colliding bodies will stick together. Okay, and the loss of the kinetic energy would be maximum in perfectly inelastic collision. All the subsequent collision are also perfectly inelastic. By the time the last block of mass 8m starts moving, the total energy loss is p% of the original energy. So what would be the value of P? So this is the situation. Initially only this m block is moving, the block of mass m is moving with velocity v, and finally what will be happening, all of these blocks will stick together and the combined mass will become how much? I think after adding you will simply get it as 16m, and it will be moving with certain velocity. And you should realize, like in each collision the linear momentum will be conserved. So whatever is the linear momentum in the system, just before the collision and after all the collision, linear momentum is not going to change. So initial linear momentum, let's say that is P is equal to mv, and we will be left up with same linear momentum here also. So that is P. So we need to find out the loss in kinetic energy. So kinetic energy is given by the formula K is equal to P square by 2m. So initial kinetic energy is simply going to be P square by 2m over here. And final kinetic energy, now you should realize this P term would be same in order to for the calculation for final kinetic energy, say Kf. So that is P is still same. So P square upon 2, and the total mass is 16m over here now. So 16m. So that will be P square by 32m over here, right? And we are required to find out delta K by K. Okay, like the a percentage change or the percentage loss of energy. So delta K will be simply equal to, you can say that is Kf minus Ki upon Ki over here. So that will be simply the numerator will turn out to be minus 15 p square by 32m, and the denominator will turn out to be, denominator is straightforward, p square by 2m, and simplifying you will simply get it as minus 15 by 16, and in percentage you can convert it into, like, that would be minus 93.75%. Okay, that is exact value, and it can be approximated as minus 94%. So decrease in or the loss in energy, that is p percent. So p is definitely 94. So option 3 would be correct. Okay, so now let's move on to next question here, 16. So this question is from Zener diode, and it says that take the breakdown voltage of the Zener diode used in the given circuit is 6 volt. Okay, for the input voltage shown in figure below, the time variation in the output voltage is. Okay, so this is the input signal. Okay, and we are looking to find out the output signal between these two terminals. Okay, and here the connection of diode in such a way that at a time only one Zener diode would be forward bias, so it will not do anything, and the another will be reverse bias. And now you should realize, like, for each half cycle, let's say from this position to this position, for each half cycle, the voltage is changing from 0 to 10 and back to 10 to 0 over here. So you should realize, since the Zener breakdown voltage is 6 volt, so from 0 to 6 volt, anyway, like for example, this diode will be forward biased, it will not do anything. And from 0 to 6 volt, it will also not undergo any breakdown, so it will also not offer any resistance over here. Okay, so like it will allow the output from 0 to 6 volt, it will allow the output voltage to be same as input voltage. Okay, so here you can say that from 0 to 6 volt, like for example, let's draw a line. So from 0 to 6 volt over here, uh, you can say there will be output voltage will be same as input voltage, but from 6 to 10, when the input voltage is exceeding the Zener breakdown voltage, the Zener diode will be acting like a voltage regulator, and it will not allow the output voltage to become greater than 6 volt. Okay, so the output voltage will be 6 volt only now. Okay, so like I think this option 2 or option 4 will be correct. And also for the reverse cycle, the reverse cycle, it will be also acting in same manner. So I think option 2 will be correct over here. Okay, so the voltage due to presence of these two Zener diodes, the voltage uh, peak will not be exceeding from the 6 volt. Okay, so option 2 is correct. So question number 16 is done. And now let's move on to question number 17. Question number 17 is from electromagnetic induction, and pretty simple. A small bar magnet is moved through a coil at a constant speed from one end to the other. Which of the following series of observation will be seen on the galvanometer G attached across the coil? And that is basically Lenz's law. So when magnet is entering into the coil, okay, so the magnetic flux is increasing, so current in the coil will be in such a direction so as to oppose the change. So in order to oppose the change, current would be in this direction. Okay, and once the magnet completely enters inside the coil, the flux will no longer be changing, as it is moving continuously inside the coil only. Okay, so as long as it is moving inside the coil, flux will not be changing, so induced EMF will be equal to 0, so no current will be induced, also the current will be 0, so reading of the galvanometer will also be 0. And once it starts to come out of the coil here, the flux will start decreasing, so the current will flow in opposite direction. Okay, so obviously the option 2 is the right choice. Okay, so that's it. It's question 17. And now let's move on to question number 18. Question number 18 is another question from collision here. A particle A of mass m by 2 moving along x-axis with velocity v naught collides elastically with another particle B at rest having mass mb is equal to m by 3. If the particle moves along x-axis after the collision, the change delta lambda in de Broglie wavelength of the particle A in terms of de Broglie wavelength lambda naught before the collision is. So basically, as we understand that lambda is equal to h by mv and all. Okay, so lambda you can say is inversely proportional to v for a given object. Okay, so just we need to find out like how will the velocity be changing after the collision. So from that we can find out how the lambda will be changing and all, and we can find out the change in de Broglie wavelength. Okay. So here we are having two particles A and B, and their masses are m by 2 and m by 3, and I do not like to work in fractions, so rather what I will do, I will write it as 3m and 2m because the ratio is maintained anyway. So I can obviously, without the loss of generalization, I can do that. Okay, and before the collision, this was moving with certain velocity v naught, and this is uh, B is stationary. Okay, and we are required to find out the change in de Broglie wavelength of the particle A. So we need to find out the velocity of A after the collision. And this formula you got to memorize. Like this formula is simply, let me write down for you. Like that would be something into VA plus something into VB. This formula I suggest everybody to please remember, and that is something like MA minus MB upon MA plus MB, and that is 2MB upon MA plus MB. And in this specific situation, this VB term is 0. So this is definitely going to be equal to 0. So we are left up with this term. So that would be 3m minus 2m. So that would be m upon 5m. So that will, and VA is simply V naught. So this will simply turn out to be V naught by 5. So V naught is changing to V naught by 5. And since wavelength is reciprocal of velocity, so lambda naught will be changing to 5 lambda naught. So change in wavelength delta lambda is definitely 4 lambda naught. So option 3 is correct. So that is question number 18. Now let's move on to question number 19 here. So 19 is simple classical magnetism question. A small bar magnet placed with its axis at 30° with the external field of 0.06 Tesla experiences a torque of 0.018 Newton meter. So expression for torque is tau is equal to mb sine theta over here. Okay, so tau is given to us as how much? That is 0.018, and that is equal to mb, and sine theta, basically theta is 30°, so that is 1 by 2. So mb here we have got it as 0.036. Okay, so that is the first thing, and then we are required to find out the minimum work required to rotate it from its stable to unstable equilibrium position. So u stable uh, when the bar magnet is stable means it is making angle 0° with the magnetic field. Its potential energy will be simply minus mb, and when it is unstable, its potential energy will be simply plus mb. So work done here will be nothing but the change in potential energy, that will be simply equal to 2 times mb, and mb's value we have already got. So multiplying it with 2, we can say that it would be 0.072, okay, joules. Okay, so that is option 2, question number 19. And now let's move on to question number 20. So question number 20 is a kind of question based on information, and you must be knowing, like among all these three or all these four, the gamma rays are most energetic, and then after X-rays and so on, the least energetic are radio waves. So wavelength of the X-rays will be maximum, and the wavelength of the radio waves will be minimum over there. Okay, so I think it is straightforward. That would be question number 3. This is the easiest question you can get in any exam. So that is question number 20 for you. And the next question, that is question number 21, and it is from the optical instrument, the extra syllabus part. In a compound microscope, the magnified virtual image is formed at a distance of 25 centimeters. So the final image is forming at D, which is near point, that is 25 centimeter. The focal length of its objective lens is 1 centimeter. Focal length of objective lens is 1 centimeter here. And if the magnification is 100, M is 100 here, and the tube length is given to us as 20 centimeter, then the focal length of the eyepiece lens FE we are required to find out. So when the final image is at a near point, okay, then the magnification formula or the magnifying power formula is given by this expression, that is L upon F naught into 1 plus D by FE, right? So two specific cases we study, like when the final image is at near point and or the final image is at infinity. So here we are talking about when the final image is at near point. So when we will be substituting all the given values, M is 100, L is 20, F naught is 1, and 1 plus D is 25, and FE we are required to find out. And so after solving, like FE will be equal to 6.25 centimeter. And I think the key given by NTA is I think 5 centimeter they have given. So that is obviously not correct. So this is question number 21. Now let's move on to question number 22. Now we are having a circular disk of mass m and radius r is rotating about its axis with angular speed omega 1. If another stationary disk having a radius r by 2 and same mass m is dropped coaxially on to the rotating disk, gradually both disks attains a constant angular speed omega 2. The energy lost in the process is, okay, percentage. In percentage they are asking. So this is the idea. So this is the disk, let's say, which is rotating initially with angular speed omega, and then after another disk has been dropped over it slowly. Let's say another disk is like this. Okay, and they begin to rotate like this is rotating with omega 1, and now this is rotating with omega 2. Okay, so in this process you need to understand that the angular momentum will be constant since there is no external torque acting on the system about the axis of rotation. So angular momentum is constant, like you can say Li is equal to Lf. Okay, and here also you need to understand how much is the moment of inertia initially of the system. So initially we are having only one disk of mass m and radius r, so moment of inertia would be mr square by 2. And finally what we are having as moment of inertia, so we are having now two disks. Okay, so the first disk will be having mr square by 2 as moment of inertia, and the second disk will be having half, and its mass is given to you as m only, and its radius is r by 2, so that would be r square by 4. And ultimately you get it as the uh, solving it, you will simply get it as 5 by 8 mr square. So this is initial and final moment of inertia. Okay, so you need to understand that initial kinetic energy, the kinetic energy you can say is governed by this formula L square by 2I. So initial kinetic energy will be L square by 2I initial, and similarly final kinetic energy will be L square by 2I final. And this is the beauty of the question, that L is constant, like in initial and final angular momentum is constant. So the change in kinetic energy delta K, you can take L square by 2 simply common, and that will be 1 by IF minus 1 by I over here. Okay, and that is a percentage change since we are looking for. So simply we can divide it by L square by 2 into 1 by I over here. So L square by 2 will get cancelled, and when you will be substituting all the values which I have already written, you will get it as minus 1 by 5, which is equivalent to minus 20%. So 20% will be the loss in energy. So this is your answer. So that is question number 22. Now let's move on to next question. That is question number 23, and that is from the Bohr's model. In the line spectra of hydrogen atom, difference between the largest and the shortest wavelength in Lyman series is 304 angstrom, and the corresponding difference for the Paschen series in angstrom is. So Lyman series, you need to understand, is corresponding to the transition from higher and excited state to n is equal to 1. Okay, so the longest line 1 by lambda max will corresponds to the smallest transition, so that would be equal to r into 1 by 1 square minus 1 by 2 square, and simplifying that you will be getting lambda max is equal to 4 by 3r. Okay, and similarly for lambda minimum, the corresponding transition would be maximum over here. So that would be r into 1 by 1 square minus 1 by infinity square, you can say. Okay, and so the lambda minimum here, you will get it as 1 by r. So the difference over here, the delta lambda in case of the Lyman series, will come out to be equal to 4 by 3r minus, sorry, that is 1 by r, I must write, pardon. Okay, so 4 by 3r minus 1 by r will be simply 1 by uh, 1 by 3r. Okay, and that has been given to us as 304 angstrom, and this allows us to write 1 by r is equal to 3 into 304 angstrom. So that is given to us, and now we are required to find out the corresponding difference in Paschen series. So in Paschen series, the final state of the transition is n is equal n to some n is equal to 3. The final principal quantum number got to be equal to 3. So in that case, 1 by lambda maximum here would be r into 1 by 3 square minus 1 by 4 square, and this will give us lambda max is equal to uh, that is 144 by 7r, and similarly when you will calculate 1 by lambda minimum, okay, you will get it as r into 1 by 3 square minus 1 by infinity square. Okay, so lambda minimum, you will get it as 9 by r, and this difference now, the lambda, delta lambda, you can say Paschen, will be simply the difference of these two, and this difference will be simply 144 by 7 minus 9 into 1 by r, which is nothing but 3 into 304 angstrom. And when you will be simplifying that, you will be getting 10553.14 angstrom. Okay, so that is your answer for question number 23. Right. So now let's move on to question number 24 here. Question number 24 is also a very simple question from kinetic theory of gases. A closed vessel contains 0.1 mole of a monoatomic ideal gas at 200 Kelvin. If 0.05 mole of same gas at 400 Kelvin is added to it, the final equilibrium temperature. And I am assuming for the calculation of this that this is an insulated vessel, no heat transfer between the vessel and the surrounding. So I am assuming that internal energy of the gas is conserved. So what you can say, so before mixing the internal energy is say u1 and u2, and after mixing the combined internal energy is say u. So u1 can be written as n1 cv into t1 plus u2 is equal to n2 cv into t2. Since both the gases are same, I have taken the same value of cv in both the cases, and when they are mixed, the combined number of moles will be simply n1 plus n2, and their CV will be simply CV, and that equilibrium temperature, let's say, is T, and CV obviously will get cancelled. Sorry, here I think CV will get cancelled. So obviously the equilibrium temperature will be having expression as N1 T1 plus N2 T2 upon N1 plus N2 here. And now let's substitute the values. N1 has been given to us as 0.1 into T1, that is 200, plus N2 is 0.05 and T2 is 400, and that divided by N1 plus N2, which is nothing but 0.15, and simplifying you will simply get it as 266.67 Kelvin. So that is 24th question. And now let's move on to the last and the final question here. So that is question number 25, and that is pretty interesting question according to me. So here we are having ABC is a plane lamina of the shape of an equilateral triangle, and D and E are midpoint of AB, AC, and G is the centroid of the lamina. Moment of inertia of the lamina about an axis passing through G and perpendicular to the plane ABC is I naught. If the part ADE is removed, the moment of inertia of the remaining part about the same axis is n I naught by 6. So the idea is, if I somehow manage to find out the moment of inertia of the part DAE, I can DAE about an axis passing through G, then I will simply subtract the moment of inertia of it in I naught, and I will get the moment of inertia of the remaining part. So all the calculation or everything which I'm going to do is for the calculation of moment of inertia of this DAE triangle about an axis passing through G. So for that, what I'm going to do here is I can imagine like this whole triangle, this large triangular plate is made up of, okay, 4 smaller triangles of half the side length, okay, and 1/4 of the mass of the original one. So like, can we say that what would be the moment of inertia of each small triangle about about their respective, about their centroid? Okay, so I can simply use the result given, since it is for ABC it is I naught. So for each of these smaller triangle, since you understand that I is directly proportional to ml square, so for the larger triangle it is having moment of inertia about its centroid as I naught, and we are looking for the moment of inertia of a triangle which is having 1/4 as mass, so that is 1/4, and 1/2 as the side length, so that is 1/2 square. So basically moment of inertia of each small triangle about their centroid will be simply equal to I naught by 16. So ADE will also be having moment of inertia about its centroid, that will be equal to I naught by 16, but we need the moment of inertia of ADE not about its own centroid, but the about an axis passing through G, which is the centroid of the ABC triangle. Okay, so we need to do this thing additionally. So what we can say, like for example, moment of inertia of each small triangle about G. Okay, so that will be, we can use the parallel axis theorem. Remember, so about their center of mass or about their respective centroid, this is I naught by 16. So I can use the parallel axis theorem. Let's say its mass is m by 4. And let's say the distance between the corresponding centroid is d. So this will be something like this. And let's say this is term I can denote it as x. So that is say I naught by 16 plus x over here. I am just writing x for uh, uh, my convenience. Okay, so this is the moment of inertia of each small triangle. And now you should realize that is about G. Okay, so the moment of inertia of the whole triangle ABC, you can say, will be the moment of inertia of each triangle. Like, and this is moment of inertia of each small triangle at corners also, I must write that is at corners, because the middle one will be like having moment of inertia about G or its own centroid is same. Okay, so like this is the same thing over here, so we do not need to bother about that. So so the moment of inertia of this these triangles at the corner and plus this triangle at the center, when we will be collectively adding it, I must get it as I naught. So you can say that the moment of inertia of the middle triangle is I naught by 16, and moment of inertia of all the corner triangles, I have got it as I naught by 16 plus x, and there are three such triangles, so into 3, and that is giving us combinedly as I naught. That is about an axis passing through G, and this allows us to find out the value of x here. Okay, and x is nothing but I naught by 4. So that is what I was looking for. So this thing become I naught by 16 plus I naught by 4 over here, and now we are ready to write the final answer. So moment of inertia of the remaining part, or that is the answer would be I naught, that is the moment of inertia of the whole ABC triangle, minus, okay, the moment of inertia of the triangle ADE about an axis passing through G. So I need to subtract this I naught by 16 plus I naught by 4 into that, and you will get your answer as 11 by 16 I naught, and they are asking you the value of N I naught by 16. So N will be equal to 11 only. So that is for question number 25, and that's the end of the paper. Okay, and that's all for the paper discussion. Okay, and thank you very much for joining us. Hello everyone, my name is Ravi Ranjan Kumar, and I'm going to discuss this JEE Main 2020 4th September afternoon shift physics paper. Okay, so let's start here. So here's the first question for us, and this question belongs to Doppler effect of sound. And let me read the question for you. So the driver of a bus approaching a big wall notices that the frequency of his bus's horn changes from 420 Hz to 490 Hz when he hears it after it gets reflected from the wall. Find the speed the bus if speed of the sound is 330 meter per second. So we need to figure out first of all what all parameters are given to us in this question. Okay, so 420 hertz we can see that is nothing but the original frequency or the frequency of the bus's horn as observed by the driver himself. So that is original frequency of the bus's horn, and that is given to us as 420 hertz. Okay, and also after reflection, driver again will observe its echo, and the frequency of the echo has been given to us as f dash, which is nothing but 490 hertz. Okay, and apart from that, speed of sound here also is given to us, that is 330 meter per second, and we are being asked what is the speed of bus here. So v, that is speed of bus, is unknown to us. Okay, so this is one simple situation where we are required to find out the frequency of echo, and this could be done using very simple mirror image method. So let's try to understand. So say this is a bus and this is moving on a track. Let's say its velocity is v and it is moving towards a wall. Say this is the wall or the reflecting surface here. Okay, so in order to find out the frequency of echo, what you can imagine is the mirror image of the bus, which you can mirror image of the same bus in this reflector. Okay, so this bus will be moving with same speed v. Its mirror image will be moving with same speed v towards the wall. And now, in order to find out the frequency of the echo, since this bus is emitting a frequency of f naught, you can imagine its mirror image to also emit frequency of f naught. And in order to calculate the frequency of echo, what we can do, like we can treat the original bus as listener and the mirror image bus as the source over here. So in that case, simple one step problem it would be. So f dash, you can say, will be equal to f naught into the formula is c plus vl, because the listener is approaching towards the source, and upon C minus Vs, because the source is approaching towards the listener as well. So this will be the applicable formula here. And now we just have to substitute the values. So here f dash has been given to us as 490 hertz, and that will be equal to 420 into c is given to us as 330, and unknown is v. Like the speed of a source as well as listener, both will be same. So 330 plus v upon 330 minus v. And simplifying it, you will simply get v as 330 by 13 meter per second. And when we will be converting into kilometer per hour, what 91.38 kilometer per hour we will be getting, which can be approximated as 91 kilometer per hour. So option 1 would be true. So this is the first question. So now let's move on to the second question. Okay, and the second question here we are having from the photoelectric effect of light. Okay, so this, let me read the question. In a photoelectric effect experiment, the graph of stopping potential V versus reciprocal of wavelength obtained is shown in the figure. And as the intensity of incident radiation is increased, okay, we have to comment on that how the nature of the graph will be changing. For example, option 1 is one says the graph does not change. Option 2, slope of the straight line get more steep, straight line shift to the left, straight line shift to the right, etc. We are looking to have it. Okay, so in order to solve this question, we need to establish a relationship between stopping potential and 1 by lambda. Okay, so here this equation, that is the Einstein's photoelectric equation, that is the energy of incident photons, say hc by lambda, will be equal to the work function of the metal plus E times stopping potential, E times V. So when we will be rearranging this equation, like we can write it as V is equal to hc by E into 1 by lambda minus phi by E. Okay, so definitely looking at this form, this is a straight line, this graph but of a V versus 1 by lambda will be simply a straight line. Okay, and here you can see like this term slope, this would be the slope of this curve, that is slope is hc by E, and this would be nothing but you can say V intercept. Okay, and V intercept here we are getting it to be minus phi by E, you clearly can understand. And like for example here these all things like hc by E as well as minus phi by E, both of these terms are independent of intensity of incident radiation, so neither the slope nor the intercept are going to change. So the correct option for this question will be option number 1, graph does not change. Okay, so now let me move on to the third question. Let's have the third question here. So the third question is a particle of charge q and mass m is subjected to an electric field E is equal to E naught into 1 minus ax square. So we are having a variable electric field which is varying with respect to x axis in the x direction. Okay, so where a and E naught are constants, initially the particle was at rest at x is equal to 0. Other than the initial position, the kinetic energy of the particle becomes 0 when the distance of the particle from the origin is. So we have to find out the position where the kinetic energy of the particle will again become equal to 0. So in order to do that, we can apply a work energy theorem. So let's say applying work energy theorem, work energy theorem. Okay, so work energy theorem is simply the change in kinetic energy dk will be equal to work done by the force. Dk is equal to dw. Okay, and say dk will be equal to dw here is will be the work done by this electric force, and that will be simply q times e, and e is given to us as q into e naught into 1 minus ax square over here. Okay, so this is the force, and that multiplied with the displacement would be the work done. So multiplied with the small displacement dx, so that would be the change in kinetic energy. Net change in kinetic energy, the expression for this can be written as the integral of this thing. So q e naught is a constant, and that will come out of the integration sign. So 1 minus ax square into dx, and we can integrate it from some 0 to x. And what we are looking for, we initial kinetic energy, the particle is equal to 0. Final kinetic energy also we are looking it to be 0. So left hand side we can equate it with 0, and the right hand side will be q e naught. And like when we will solve this integral, we will be getting simply x minus ax cube by 3 will be equal, that is equal to 0. And the solution to it is obviously like x, either it will be 0 or we can have it as plus minus root under 3 by a. So like we do not have to choose the initial position as our answer, like that is the initial position origin. So the basically the distance of x is equal to plus minus root under 3a will be from the origin, it would be root under 3 by a. So option 2 will be correct here for the question number 3. Now let's move on to the next question, question number 4. So question number 4 is from the classical magnetism, that is the extra syllabus. A paramagnetic sample shows a net magnetization of 6 ampere per meter when it is placed in an external magnetic field of 0.4 Tesla at a temperature of 4 Kelvin. So some condition is given, magnetization is given, and external magnetic field is given, and the temperature is given. And the same sample is now placed in an external magnetic field of 0.3 Tesla. So the external magnetic field we have changed, and also we have changed the temperature to 24 Kelvin, and then we are required to find out the magnetization. So in order to do this question, okay, we need to remember Curie's law. Okay, so Curie's law, all of you might remember, that is the magnetic susceptibility of a paramagnetic material is inversely proportional to its absolute temperature. And how is the magnetic susceptibility defined? That is defined as magnetization upon uh, intensity of magnetizing field. So I by H is the magnetic susceptibility, and that is equal to, you can say, or rather we must use proportionality over here. So it will be proportional to 1 by T, you can say. And H also, like the external magnetic field B naught is given by mu naught times H. So B naught, the external magnetic field, is proportional to H. So we can substitute it over here. So I by B naught, okay, is directly proportional to 1 by T, we can say. Or alternate way of writing this is like I into T upon B naught is a constant. Okay, so we can utilize this situation to write something like I1 T1 upon B naught 1 will be equal to I2 T2 upon B naught 2. So everything apart from I2 is given to us. So let's substitute the value. I1 is given to us as 6 ampere per meter. T1 is given to us as 4 Kelvin, and B naught 1 is given to us as 0.4, and that must be equated with I2, which is unknown, and T2 is given to us as 24 Kelvin, and B naught 2 is given to us as 0.3. And after solving, after doing our calculation, I2, we will get it as 0.75 ampere per meter. So option 1 is true. So that is for question number 1. So let's move on to the next question, question number 5. So question number 5 is from the gravitation, and pretty simple one. A body is moving in a low circular orbit about a planet of mass m and radius r. The radius of the orbit can be taken to be r itself. Then the ratio of the speed of the body in the orbit to the escape velocity of the planet is. So we need to know about two things. What is the orbital velocity in a circular path? Okay, so the expression for this is nothing but gm by r, where r is the radius of the circular orbit, which in this situation has been given to you as capital R only, which is same as the radius of the given planet. Okay, so this is V naught. And also we must know what would be the escape velocity of at the surface of the planet, and this expression is given by root under 2 gm by r. This is the escape velocity at the surface of the planet, and very simple thing has been asked to us, that is v naught upon ve, and that will be simply equal to, when you will be dividing, this will be 1 by root 2. So option 2 is correct. Okay, so that is question number 5. So now let's move to question number 6 here. Okay, so question number 6 is also very simple one, and that is from the work energy chapter. And let me read the question for you. A person pushes a box on a rough horizontal platform surface. He applies a force of 200 Newton over a distance of 15 meter. Thereafter, he gets progressively tired, and his applied force reduces linearly with distance to 100 Newton. The total distance through which the box has been moved is 30 meter. What is the work done by the person during the total movement of the box? So we must realize that the person is applying variable force. So for the first 15 meter, he is applying 200 Newton, and then he is decreasing the exerted force linearly from 15 to 30 meter, from 200 Newton to 100 Newton. So it would be best to have a F versus force versus displacement graph. Okay, so let's have a force versus displacement graph. Let's say force is in Newton and displacement is in meter. Okay, so initially he is traveling from say some 0 to 30 meter. So for the first 15 meter, the force applied is equal to 200 Newton, and thereafter from 15 to 30 meter he is decreasing the force linearly from 200 Newton to 100 Newton, like this. Okay, and this is the graph of F versus X from 0 to 30 meter of the travel. Okay, so work done by this force, this variable force, will be simply equal to the area under curve of X versus F versus X graph, area under curve of fx graph. And that is very easy to find out. Like that will be equal to, you can find out the area of this rectangle here and then area of this trapezium over here. So area of this rectangle, you can say, will be simply equal to 200 is its height and 15 is its width, and the area of the trapezium would be half into sum of parallel sides, which is 200 plus 100, you can say, and into its height is again 15 meter. So solving this, you will simply get it as 5250 joules. Okay, and that is option 1. So that was question number 6. So now let's move to the next question here. Question number 7. Question number 7 is also a very simple question belonging to the chapter of capacitors. So here we are having sorry, a capacitor C is fully charged with a voltage of V naught. So what we are having is a capacitor which is of capacitance C, and it is fully charged to a voltage of V naught. And we want it to add to, after disconnecting the voltage source, it is connected in parallel with another uncharged capacitor of capacitance C by 2. So another uncharged capacitor we are having of capacitance C by 2, which is initially uncharged. Okay, and these we are connecting in parallel, means something like this we are trying to do. Okay, they are connected in parallel. This capacitance is C and this is C by 2. So there will be rearrangement of charge, and we are having a simple formula for the energy loss or loss of energy here, and that is given by, like for example, if you uh, connect two capacitors. Okay, the formula is half C1 C2 upon C1 plus C2, or you can have the formula V1 minus V2 or V1 plus V2 square. V1 minus V2 will corresponds to when the polarity will be same if you connect it like this, and if the reverse polarity is connected, then the formula will be V1 plus V2 square, depending upon. So, but here in this situation, this like V1 is equal to V naught, but V2, like the another capacitor is simply uncharged, so this V2 is simply equal to 0 and V1 is equal to V naught. So there is no big deal in this. Okay, so just substituting the value half into C1 is C, C2 is C by 2, and that is C plus C by 2 here into V naught square, and simplifying this simply you will get it as 1 by 6 CV naught square. So option 3 is correct, right? So that is question number 7. Okay, so let's move on to now question number 8 here. So question number 8 is from LR circuit. So a series LR circuit is connected to a battery of EMF V. So what kind of circuit we are having? So that is LR circuit. This is R, this is L, and this is connected to a battery, and there is switch, and let's say at t is equal to 0, we are closing the switch. So say this is R and this is L and this is V, etc. And we are required to find out the time at which the energy stored in the inductor reaches 1 by n times of its maximum value. So energy stored in the capacitor formula is simply half Li square, okay, where I is the instantaneous current, and the instantaneous current as function of time, it will be simply given by some I naught into 1 minus e to the power minus RT by L. So this is the expression. Okay, so U is directly proportional to I square. So for U, you can have an expression like that, like U is equal to U naught into 1 minus e to the power minus RT by L and the square of it. And the energy we want it to be the 1/nth times of its maximum value. Maximum value is definitely U naught. So 1/nth of that, like that would be simply U naught upon N. And you just have to simplify that expression, and simplifying that you will simply get it as T is equal to L by R into ln root n upon root n minus 1. Okay, so that is which option here we are having? That is option number 4 is true, right? So that is question number 8. Now let's move on to question number 9 here. Question number 9 is simple, a definition based question. Okay, so we have to just simply match the process with the condition. So adiabatic process, just by definition we understand, like adiabatic process delta Q will be equal to 0. Isothermal is when the temperature is 0, temperature is constant. So that simply gives us like delta U will be equal to 0. And similarly isochoric process, the volume is constant. Volume is constant, so work done by the gas will be equal to 0. And for isobaric process, neither delta W nor delta U nor delta Q, neither of these will be equal to 0. So obviously we have to match. So option 1, adiabatic process, like 1 will belong to B here, that is delta Q is equal to 0. 2 will belong to delta U is equal to 0 is D. So 2 is D here. And 3 is isochoric process. Isochoric process delta W is 0. So that is A. And obviously this one is C. Okay, so I think this would be the third option, B, D, A, C. Okay, so third option is correct. That is the simplest question you can have. Okay. So now let's move on to the next question, that is question number 10. So in this question, this is the question from the moment of inertia. And the question states that for a uniform rectangular sheet shown in the figure, the ratio of moment of inertia about the axis perpendicular to the sheet and passing through the O, the center of mass, and O dash, that is the corner point, is. Like you have to find out the ratio of I naught upon I naught dash. Okay, so let's try to find out the value of I naught. Okay, about this axis. Okay, so what would be I naught over here? I think this is a very simple formula. Let's say this length A, this is the length A is 60 and B is 80, that is given to you. Do not need these values in fact. So I naught according to the formula simply is 1 by 12 M A square plus B square, and that is known to you. And similarly I naught dash also you can find out about this axis here Okay, although you are supposed to remember the formula, but I am going to justify it anyways. So about this axis here, the moment of inertia, you can write it as 1 by 3 mb square, and about this axis, you can write it as 1 by 3 ma square, and using perpendicular axis theorem, you can simply write it as 1 by 3 ma square plus b square. Or alternatively, since you can also use parallel axis theorem, so since I naught you know, and o dash, the axis passing through o dash is parallel to the axis passing through o, so you can also apply the parallel axis theorem and you will still get the same result. So I naught and I naught dash we have known, and we are required to find out I naught upon I naught dash, and this will simply like a square, ma square plus b square term will get cancelled, and you will be left up with 1 by 12 and 1 by 3 here, and which effectively will give us 1 by 4 as our answer. So option 3 is the correct choice. So that was question number 10. So now let's move on to question number 11 now. Okay, so the question number 11 is again a simple question. Let's try to figure that out. So let me draw the diagram for us. Like, first of all, let me read the question. Two identical cylindrical vessels are kept on a ground and each contain the same density of liquid. The area of base of both the vessel is S, but the height of liquid in one vessel is X1 and in another vessel it is X2. When both the cylinders are connected through a pipe of negligible volume very close to the bottom, the liquid flows from one vessel to another until it comes to equilibrium at a new height. The change in energy of the system is. So let's say let's draw two cylindrical vessel. Let's say this is one of the cylindrical vessel. Okay, this is one of the cylindrical vessel we are having. Okay, and say liquid is filled in this vessel to a height of some x1 that is given to us. Okay, and its cross-sectional area is S. Okay, its cross-sectional area is S, that is also given to us. And we have another cylinder which have same cross-sectional area. Okay, let's say that is also S, but only difference is the liquid is filled only to a height of x2 in this cylinder. Okay, and afterwards what has been done is like near the bottom they have been connected with a very thin pipe. Okay, they have been connected with a very thin pipe. So what will happen here is the liquid will flow from the left container to the right container until the level becomes same. So like initially the difference between these two levels, you should realize this, the difference between these two levels you should realize is x1 minus x2. I'm assuming x1 to be greater than x2 over here. Okay, so now you should realize that when the level will become equal, and since the cross-sectional area is same, okay, so this something like this would be the final level. Okay, and this width, this level will go down and this level will go up. Okay, by how much? By how much displacement it would be? That would be half of this quantity. That would be x1 minus x2 by 2. Okay, so effectively the previously so effectively what we have seen is like what change is happening over here. Like whatever this liquid is there, now it has moved on to this part effectively. That is the change, and the remaining part is just like it. Okay, so this is the effective change. Okay, so we are looking for the change in energy of the system, basically change in gravitational potential energy of the system. So gravitational potential energy is decreasing. Okay, so like the change in gravitational potential energy, delta U, and mod of it I will simply writing out, that is definitely decreasing. So that would be the mass of the shaded part, like which has effectively moved from this position to this position here. So what would be the mass of this shaded part? So the density is given to us as D, and cross-sectional area is S, and its height effectively is nothing but x1 minus x2 by 2. Okay, so this is basically the mass. So this is mass times G times and the decrease in the center of mass of that part. So center of mass would be middle, somewhere here at the middle and somewhere here at the middle. So the displacement of center of mass in vertical downward direction, this quantity will also turn out to be x1 minus x2 by 2 only. So this is x1 minus x2 by 2. Okay, so this will simply give us 1 by 4 GDS into x1 minus x2 square. So you can also write x2 minus x1 square, because it does not matter, because anyway you are squaring it. So option 1 is the right choice over here. That is question number 11. So now let's move on to question number 12. So here we are having a logic gate question, and that is a little bit tricky, although if you follow the logic, it is very, very simple. So here we are seeing all the gates that has been shown in this question are NOR gates. Okay, so NOR gates here, in this NOR gate, the upper NOR gate here, we are putting the input signal, both the input signal are A and A. Okay, so like the output signal here would be, you can say NOR gate through the NOR gate when it would be passed. So that would be A plus A bar. Okay, and A plus A is also A, so that is effectively A bar. And similarly, this would be B plus B bar, and that would be effectively B bar. And this would be C plus C bar, and that would be effectively C bar. So now this another NOR gate, although we are used to having only two input signal, but here rather we are having three input signals. Okay, so what would be the output of it? So this is OR, a NOR gate over here. So first of all, output signal of the OR gate will be simply A bar plus B bar plus C bar. And since this is NOR, we must put another bar over it. Okay, and just use the some formula for Boolean algebra. So this will turn out to be A dot B dot C. So this A dot B dot C, what does the logic says? The logic says that if all these inputs A, B, and C, or if all these inputs A and B and C, all of it is equal to 1, then only the output signal will be equal to 1. So this definitely is the logic for an AND gate. Okay, so this, the answer would be AND gate of this, option 3. Okay, so that is question number 12, and now let's move on to question number 13. Okay, so the value of current I1 flowing from A to C in the diagram, we are required to find out. A pretty meshy looking diagram we are having. Okay, so this current I1, okay, this is the current from A to C we are required to find out. And the like the best thing over here is like there is no resistance of this main wire over here. Okay, so like uh, irrespective of like what other resistances are in this system, we can simply write KVL in this loop. Please understand, we can simply write KVL in that loop, and that will allow us to write like 8 minus I1 into total resistance is 4 plus 4. So that is 4 plus 4 we can write, and that will be equal to 0. So this simply will give you I1 is equal to 1 ampere. So the beauty of this question lies simply like irrespective of what other resistances are, we can simply find out the current I1, okay, by writing the KVL in the shown loop over here. So that is question number 13. So now let's move on to the question number 14. 14 also, like the electromagnet JEE main is basically fond of asking electromagnetic wave question, and all of the all based on same concept. So I think most of the people might have already got this question. But anyway, let's try to solve. So what they have given here is they have given the expression for the oscillation of electric field. So E is given to you, that is E naught into x cap plus y cap. X cap is basically, you can say I cap, and j cap they are trying to give, and sine kz minus omega t. So what we can make out of it, like this kz minus omega t. So from this we can simply say that the electromagnetic wave is traveling along positive z-axis. So that is one thing to notice. Okay, and the another thing to notice is the electric field is oscillating along x cap plus y cap direction. Okay, so a few things we need to understand when we are to write the expression for magnetic field. First of all, its phase would be same as the phase of electric field. So here we are having sine kz minus omega t. So in the expression for the oscillation of magnetic field, we should also have sine kz minus omega t. So option 4 you can simply exclude here. Option 4 will never be true. And the another thing is the magnitude of or the magnetic field amplitude B naught will be equal to E naught by C. Okay, and that is the case in each and every one. So this does not help. The only thing that will be helping us is the fact that the velocity vector C bar will be along E cross B. Okay, so we have to choose the direction of magnetic field, oscillation of magnetic field such that E cross B is along C, and C we have already seen is moving along Z axis over here. So let's try to have a simple diagram over here. So let's say this is X axis and this is Y axis, and Z axis is a direction which is coming out of the plane in which the C bar is there. So this E bar is along X cap plus Y cap. So this is the direction of E bar. So just by using the right hand rule, like B should be in this sense. Okay, this would be B bar. Then only, like for example, if you curl your finger from E to B, then your thumb will be pointing towards the outward direction, which is along C. So B is definitely like this. You can say in the second quadrant. So definitely the unit vector will the component of unit vector along x-axis would be toward negative x-axis. So that would be minus x cap, and y component would be positive one. So minus x cap and plus y cap. So definitely option 2 will be true. So that is question number 14. Let's move on to the next question. Question number 15. So this is question number 15 over here. This is another simple question. A small ball of mass m is thrown upward with velocity u from the ground. The ball experiences a resistive force m kv square, where v is its speed. Okay, resistive force simply means it will be directed in the direction opposite to the instantaneous velocity, and we are required to find out the maximum height attained by the ball. And you should realize like the ball during its motion will be experiencing, apart from resistive force, it will also be experiencing the force due to gravity. So say this is the ball and this is the ground level. It has been projected vertically upwards. So when, let's say, its velocity, it is here, its velocity is v, so it would be experiencing two forces. One would be mg and the another would be the resistive force, that is mkv square. So like if you write the acceleration in this direction, acceleration I'm taking in the direction of velocity, so the expression for velocity acceleration would be ma is equal to like negative of the net force over here, that would be mg plus m kv square. Also you can write, and m will get common and get cancelled. And here we are looking for the maximum height. So a we need to represent in the differential form of v and y. So a we can write it as v dv by dy, v into dv by dy. I will writing for a, and that will be equal to minus g plus kv square. So here we have got a nice differential equation in v and y. Okay, and that is also in variable separable form. So g plus kv square, and we have a minus sign also, and that will be dy. And by putting appropriate limits, so y, the initial value of y is 0, and we want to raise it to the maximum height. Okay, and initial velocity is u, and at maximum height the velocity will be simply equal to 0. So just by solving this differential equation, you will get the value of h as 1 by 2k ln 1 plus ku square upon g. So which option would be true? So option 3, I guess, is the right choice. So that is question number 15. So let's move on to the next question. That is question number 16. This is from the nuclear physics and simple calculation of binding energy, or only like without calculator, like it is going to take time. So but the idea is, if you decide to do the calculation straightforward, okay, so it is not going to take much time. Okay, if you decide quickly that you have to go for the calculation. Okay, so here we are being asked the binding energy per nucleon. Binding energy per nucleon will be defined at binding energy per nucleon, and number of nucleons in a nucleus will be equal to its mass number. So EB by A, we can say. And how we will be finding out the binding energy of a given nucleus? So that would be mass defect times C square, and that divided by its mass number. So we have just to do our calculation. So let's try to find out the mass defect first of all. The mass defect would be nothing but mass of the constituent nucleons minus mass of the nucleus itself, and that multiplied with C square. Okay. So here, mass of the constituent nucleons will be 50 is the number of protons, and mass of each proton has been given to us as 1.00783 AMU, and mass of the neutrons will be, so number of neutrons would be 120 minus 50, so that is definitely 70, and the mass of each neutron is 1.00867. And in this I must subtract the mass of the nucleus itself, which is given to us as 119.902199. So this is the mass defect in AMU, and 1 AMU is equivalent to 931 mega electron volt. This conversion factor they have given, so that multiplied with 931 mega electron volt and a little bit of calculation will give you result as 8.50 mega electron volt, which is option 1. So that is for question number 16. Simple calculation. Okay, so now let's move on to question number 17 here. And now here, like what I can see, there is a little bit problem in question number 17. The keys given are not matching with the answer I have been getting. So let's try to discuss this. So let's look at the language of the question very, very closely. A circular coil has a moment of inertia 0.8 kg meter square around any diameter and is carrying current to produce a magnetic moment of 20 ampere meter square. Okay, so and the coil is kept horizontally in vertical position and it can rotate freely around a horizontal diameter. So let's say the plane of the paper is a vertical plane, and let's say this is the coil which we are looking for. Okay, and this is in horizontal plane and it is free to rotate about a horizontal diameter. So it is free to rotate about this. Okay, and let's say the magnetic field is given to us as in vertical direction. So let's say magnetic field is in vertically upward direction here. Okay, so if the sense of current is, let's say, for instance, let's choose it like that. Okay, so the direction of magnetic moment will be coming out of the plane. So initially, the angle between the magnetic moment vector and the magnetic field vector, initially the angle between them is given to us as theta I is 90 degree, you should realize. And they have said that you are required to find out the angular speed of the coil after rotating by 60 degree. The angular speed the coil acquires after rotating by 60 degree. So initially it was making 90 degree with the field vector. The magnetic moment vector is making 90 degree with the field vector. And after rotating by 60 degree, the final angle it will be making, okay, will be 90 degree minus 60 degree, which is equal to 30 degrees. So this is theta I and theta F. And now in order to find out the final angular speed, you must try to use the principle of conservation of energy over here. So delta K you can say will be equal to minus of delta U. Like kinetic energy will be increasing at the cost of decrease in potential energy. So kinetic energy about a diameter for the ring, you can write half, and its moment of inertia would be simply moment. Its moment of inertia is given to us, I think, about this diameter. So that would be simply 0.8 into omega square over here, and minus delta u. U you should realize is given to you know the formula, that is nothing but minus m dot b, or you can say minus mb cos theta, right? So minus mb cos theta, so that is delta u will be equal to uf minus ui, and taking negative of that, that will be simply minus minus plus, so it will be simply mb cos theta f minus cos theta I. So cos 30 degree minus cos 90 degree. Okay, and after substituting the value, we have been given the value of m and b also. So the value of m has been given to us as 20, and the value of magnetic field has been given to us as 4, and the cos theta will be nothing but root 3 by 2, and this cos 90 will be definitely equal to 0. And after substituting all these values, omega that you will be getting is 10 into 3 to the power 1 by 4 radian per second. So neither of the options given is this. So definitely no key is matching over here, no matching keys. So this must be taken care of, because the official key that has been given by JEE, given by JEE board here is option 1, which is definitely not true. So that is 10 into 3 to the power 1 by 4. Okay, so that is question number 17. We are having an error in this. So now question number 18, let's look at. So this is simple question of dimensional analysis. Okay, and X is a quantity which is given by IF v square upon w l to the power 4. Okay, so obviously its dimension will be also same as the dimension of this quantity over here, where I is the moment of inertia, f is force, v is velocity, w is work done, and l is the length. So let's write the dimension of each and every term. So for moment of inertia, what would be the dimension? That is simply going to be ml square. The dimension of force, that would be mlt minus 2. Dimension of velocity, so that is going to be LT minus 1. Okay, and the dimension of work would be nothing but ML square T minus 2, and that will be L to the power 4. And after simplifying, after substituting every, like cancelling things, you will be getting M L to the power minus 1 T to the power minus 2 over here. Okay, and you should notice that is same as the dimension of energy density. Okay, energy density is nothing but energy per unit volume. So here the correct choice would be option 2. Okay, so that is question number 18. So now let's move on to question number 19 now. So question number 19 is also very simple. When a cube of metal is subjected to a hydrostatic pressure of 4 gigapascal, the percentage change in the length of the side of the cube is close to. So according to the definition of the bulk modulus, as we all know, that bulk modulus is defined by delta P upon minus delta V by V. Okay, so you can rearrange it to get delta V by V is equal to minus delta P by B. Okay, so now you are having a cube of metal. So for cube, we can write like V is equal to L cube and all. So delta V by V, we can definitely write it as 3 times delta L by L. So now substituting it, so that would be delta L by L, 3 times delta L by L. 3 will go another side, and you can have delta P by 3B. Okay, and if you will take mod sign over here, we will get rid of this negative. Okay, because they are just asking the percentage change. Okay, the absolute value of percentage change. And when you will be substituting the value, so delta P has been given to us as 4 into 10 to the power 9, and that divided by 3 into bulk modulus. Bulk modulus is 8 into 10 to the power 10, and doing our calculation, you will get it as 0.0167. So in percent, you can represent it as 1.67%. Okay, so that is for question number 19. So option 2 will be the right choice. Question number 19 is done. So now let's move on to question number 20. So question number 20 is again from moment of inertia. So consider two uniform disks of same thickness and different radii. R1 is equal to R and R2 is equal to alpha R made of the same material. If the ratio of their moments of inertia are I1 and I2 respectively about their axis, and is I1 by I2 is given by 1 is to 16, then the value of alpha you have to find out. So we all know that the moment of inertia here will be directly proportional to m times r square, where m is the mass and the r is the radius over here. Okay, and like since the density, they are made up of the same material, density will be constant. So m can be written as simply, since they are having same thickness, so m is can be written as sigma r square, and sigma is same for both because same density and same thickness they are having. So m is directly proportional to r square. So collectively you can write that I will be directly proportional to r to the power 4. So we can simply write it as R2 by R1 is equal to I2 by I1 to the power 1 by 4. And I2 by I1 has been given to us as 16. So 16 to the power 1 by 4. Okay, and that will be equal to simply 2. So R2 by R1 definitely is alpha. So alpha we are getting it as 2 here. Okay, so option 1 will be the right choice. So that is question number 20. So let's move on to the next question, question number 21. So orange light of wavelength 6000 into 10 to the power minus 10 meter illuminates a single slit of width zero point 0.6 into 10 to the power minus 4 meter. The maximum possible number of diffraction minima produced on the both sides of the central maxima is. So we know for the diffraction, for minima, the condition is that n lambda got to be equal to d sine theta. That is the condition for the diffraction minima. Okay, so from that you can see that the sine theta, which we are getting, sine theta will be equal to nothing but n lambda by d, and the sine theta got to be less than 1. Okay, I am also not writing the equality here also, because sine theta means theta is equal to pi by 2. That will not be any position on any of the screen, you should realize. Okay, like that will be theoretically present, but practically it will not be possible. So sine theta got to be less than 1 over here, right? So here we can say that n is will be less than d by lambda, and when we will be substituting the value of d and lambda given in the question, d is given to us as 0.6 into 10 to the power minus 4, and lambda is given to us as 6000 into 10 to the power minus 10 here. Okay, and solving this you will be getting it as 100. Okay, so what we have got here is n is less than, n got to be less than 100. So equality sign is not there. So the maximum value of n will be only 99. So 99 minimas will be on the upper side of the central maxima and 99 will be on the lower side of central maxima. So total number or maximum number of minima both side of the central maxima will be double of 99, so that would be 198. But the official key they have released, the answer given is 200. Okay, so according to my opinion it should be 198, because the theta is equal to pi by 2 is a theoretical value only. Like for example, this is the slit, okay, and this is the screen. Okay, so if theta is equal to pi by 2, you will take like the wave will emerge in this direction and may not never reach the screen. Okay, so theta is equal to pi by 2 will only be hypothetical value, and even if you count the minima, that would be at infinity. Okay, and should not be practically counted. So maximum number of minimas you must realize should be equal to 198. Okay, so this is one other a change I am suggesting over here for question number 21. Now let's move on to the next question, question number 22. And this question is also very simple. That is from the displacement method of measuring the focal length of a given lens. And let's look at the data. The distance between an object and the screen is 100 centimeters. So distance between the screen and object 100 centimeter. Let's write. And the lens can produce real image of the object on the screen for two different position being between the screen and the object, and the distance between the two position is 40 centimeters. So the displacement is given to you as 40 centimeter, and you are required to find out the focal length of the lens. In order to do that, you can find out first of all the power, the focal length of the lens over here, and that is governed by one simple formula, that is capital D square minus small d square upon 4 times capital D. And let's substitute the value. That would be 100 square minus 40 square upon 4 times 100. And simplifying this, you will simply get it as 21 centimeter, or you can say 21 by 100 meter. So the power in diopter is nothing but reciprocal of the focal length. Okay, so the reciprocal of focal length will be simply 100 by 21 over here, and that is meter inverse, or you can say meter inverse is same as diopter. So this would be the power, and the power they have given is n by 100. So we have to find out the value of n by 100 over here, n by 100 diopter. So n comes out to be, by equating, okay, that is 100 into 100 upon 21. And this, like if n, the nearest integer, you will be getting it as 476. But the official key they have released is, I think they have released, they are saying that n is 5 and like that. But I think there is some problem. There is some error in the official key. The answer got to be 476. Okay, so that is for question number 22. Now let's move on to question number 23. Question number 23 is the simplest question. You can have the speed versus time graph of particle is shown in the figure. The distance traveled in meter by the particle during the time interval t is equal to 0 to t is equal to 5. Okay, so like here the distance traveled will be simply the area under curve of speed versus time graph. So in order to do that, like first of all, you should realize that at t is equal to 5, the speed is 8 meter per second. Okay, but they should have marked this like with dotted line, because it is not very clear that whether the speed at 5 second is exactly 8 meter per second or not. But anyway, we have to assume that. So the distance traveled would be this area of triangle, and this area here, or distance traveled over here, will be simply equal to half into base, that is 5, into height, that is 8. So that will be simply equal to 20 meter will be your answer. So that is question number 23. And question number 24 is again a very simple question. Four resistances are given to you: 40 ohm, 60 ohm, 90 ohm, and 110 ohm. Makes the arm of a quadrilateral ABCD across AC is a battery of EMF 40 volt, and internal resistance are negligible, they have given. And we are required to find out the potential difference across B and D. So this is the point B and this is the point D over here. We need to find out the potential difference between these 2 points. Okay, so what we can do, let's try to find out VB minus VD over here, right? And for that, let's say the potential here is 0. So potential here, you can assume it to be 40 volt. Okay, so see, like in the upper branch, the potential will be divided, and in the lower branch, the potential will be divided. Like this 40 volt potential will be divided in the ratio of their resistances. So like this is 40 is to 60. So like you can say the ratio will be like 2 is to 3. Okay, so the voltage across BC will be simply equal to 3 by 5 into the total voltage across AC, that is equal to 40. So you can say the potential at B, that is simply equal to VB. And similarly, VD, you can say like VD will be in what ratio this will be divided. So that would be 9 is to 11. So that would be 11 upon 20. into 40 will be VD. So when you will be doing VB minus VD, that is a simple calculation, and you will get it as 2 volts simply. Okay, so that is for question number 24. And now question number 25 is another simple question from thermodynamics. The change in the magnitude of the volume of an ideal gas when a small additional pressure delta P is applied at constant temperature is same as the change when the temperature is reduced by a small quantity delta T at constant pressure. Okay, and you are required to find out, like the temperature and pressure are given to you, and you are required to find out the value of C, which would be delta T upon delta P, etc. So we are talking about the two conditions over here. One is the constant temperature condition, and the another is constant pressure condition. So at constant temperature, when T is constant, you can say PV is constant. Okay, so you can definitely say that delta V by V will be equal to nothing but minus delta P by P. Okay, so that is the one of the situations, that is say one. And then in another situation they have given constant pressure, so P is constant simply means that V by T is constant. Okay, and that allows us to write that delta V by V will be equal to delta T by T. Okay, so that is the second one. So like volume is same and the change in volume in both the situation is also same. So left hand side of both these equations are same, and the absolute value we have to compare. So we can say that delta P by P and absolute value of it will be equal to delta T by T over here. So here we are looking for delta T by delta P, which is C, and this will turn out to be T by P, and T they have given to you as 300 Kelvin, and pressure they have given to us as 2 atm. So this will be 150 Kelvin per atm. So the answer got to be equal to 150 over here. So that's it. This discussion is over, and thank you very much for joining.